Thank you, Paul, for organizing this. I know it's been a lot going on with the past month. And I just want to congratulate everyone who's just been contributing to open source like observability projects. I think it's really important that we continue to contribute to open source. It's one of my favorite things to talk about. I work at a company that is pretty heavily involved in open source from like a maintaining standpoint, but also like trying to figure out the best ways to contribute in the type of world that we're in. And I'll talk about like the company I work for briefly. And really this talk doesn't involve much about open telemetry as like a lot of other talks do. This talk is mainly about some of the tools that you can mainly use in your data center to start observing for free. I've been working at a SRE at Oscar Health for a little over 2 years now. And last year we needed to kind of reduce some of the tooling that we did use in our observability platform, specifically in the data center, but also for our product engineers for what they do. And I want to talk a little bit about why like observability is super important for what they do. So at Oscar Health, we really care about the member experience. Like we also provide Ensure, but we're really inclined to the member experience. And so we first do that by focusing on the experience and figuring out a way to like fix healthcare. And a lot of issues with like healthcare has to do with the fact that navigating through the experience can be really difficult. You might not know what the cost of going to see a visit might be. You might not necessarily know that the issue that you do have is correct for that doctor that you want to do, which is typically called like care routing. We have a virtual integrated platform for concierge teams. We have doctors on call. Actually, it's funny being an SRE to say that we actually have doctors on call for our telemedicine program. And then thirdly, like we use data science to help members find a higher value care. We understand like the pain in like hospitals and physician values. A lot of times you'll get this information through multiple resources that you're not necessarily sure if they're valuable or not. And then we do a bunch of partnerships with a bunch of high value other hospitals and physicians. And then fourthly, we use like a lot of technology. One of the reasons why we've been able to kind of move so fast out of the last couple of years, one of the last health insurers that actually filed to be a health insurer in New York was in the 90s, and we were the next one in 2012. So it kind of even tells you how hard it is to move into like an industry of this space just because of the compliance and the regulatory issues. And then you essentially have to spin up, a whole new set of staff for each state that you move in. And to talk a little bit about some of the features that we primarily like give to some of our members is you can get cash for like walking, you can talk to a doctor 24/7, and you can message a dedicated healthcare team. And it's a little bit of our product interface. When you have our insurance, you can go through the app and see all these things. One of the reasons why observability is important for us is because a lot of times our response times are based off of legal implications, meaning that if a doctor has a queue of patients that they need to see or take care of, if their dashboard or whatever their queue management system isn't correct and they're not able to identify patients who need to be cared of right away, that also impacts their quality of care. So it's really important for us from a technology standpoint as we embed ourselves with these different platforms with doctors that are in our platform, with our care providers and nurses. It's important for us to make sure that we always return the best results when it comes to providing care. And also you don't want to be given the wrong information too when it comes to medical insurance and things like that as well. So status updates is something that is very important. And we say this because actually compared to a lot of our members, a lot of our industry competitors, we do about 30% better in other areas. So for like online accounts, monthly active users, mobile users and stat tracking. Another interesting thing that I didn't point out is that our membership is pretty much equal across all age groups between 20 and 35 and 35 and 45 and 45 and 60 and so on. And the online engagement between those age groups are all the same. So it's very interesting to see, like even in groups that we probably wouldn't expect to be to provide software that is as accessible, they find ways to use it and integrate it. So I want to talk a little bit about what is cloud source, open source. What is data center observability? And there's a lot of things to like talk about. There's infrastructure monitoring, there's application performance monitoring, there's security analytics. You have the cloud monitoring and SaaS solutions that they give you. You have DevOps analytics, you have container monitoring, you have compliance, you have search and reporting features that you need to implement. You have alerts, application insights. Now we're getting the cognitive insights, which has been around for a few years now. You know, ways to optimize your data, telling logs, parsing logs, different log patterns. But today I wanted to focus on two projects that I think are really well, that has helped us kind of start the refactoring that we did about a year ago, and some of the important principles behind that. And one of the tools is a little bit more extensive than the other. OpenTelemetry is a great project where it has a lot of hooks into other tools. I have one tool that might not be, you know, as great, but we're about to dig into that. And building a monitoring infrastructure is a complex undertaking, as we know. We've heard about this a lot today. This is something that can interact with multiple different parts of other systems. Building monitoring infrastructure requires like a lot of people to be considerate and also have a global perspective. Most importantly, building monitoring systems also requires like a lot of touch. Distincting between monitoring systems with bad ones and good ones could impact so many different resources in your data center, such as utilization, bandwidth, and security. So one good book to like kind of read when you're thinking about starting your observability project is this one book here is Practical Monitoring, and they have about 2 chapters about anti-patterns and best practices for monitoring. And it's a little funny that I'm giving a talk about some tools, but I generally do agree that one of the things that they do point out here is tool obsession. And a tool-driven team will not be effective as a mission-driven team. So when the mission is defined by writing software, analysts become, you know, captive to features and limitations of their tools. Employees who think in terms of the need in order to accomplish their mission will seek tools that will meet those needs and keep looking for it if their requirements aren't met. Sometimes we can't even decide, you know, whether to build our own tools. So this leads to like kind of a frustrating, you know, work environment sometimes when people try to like justify tools that might be a little bit more favor or might be here or there, but not really kind of focusing on the principles needed to actually get the job done. And in monitoring as a job, you know, I do work on it as an SRE at Oscar, and I am in charge of our client libraries, our logging solution, our tracing libraries for our product and our data infrastructure. And it's really hard to do this alone. I had to kind of, even with just my team, I had to kind of formulate a committee to look at everything that was getting done. Because we run in a mono repo, it's a lot easier to know what libraries people are using to instrument their code and find ways to standardize that. Because I do own all the observability tooling from a library perspective, it's a little bit easier for me to kind of be able to make standardized decisions across my company. That might not be the case for large organizations, but for us, we have around about 6,000 status endpoints within our infrastructure, comparing the data center and as well as our product infrastructure as well. So this kind of goes to call out that monitoring is everyone's job. You can't really build monitoring for products and tools that you don't understand. And 2 more anti-patterns is monitoring as a crutch. A lot of things that I see other companies doing, even just my team in general last year, and probably still doing this, you know, subconsciously today, is trying to add monitoring when an issue breaks in production. So if something happens, say, oh, we're monitoring again, and you know, if it doesn't happen again, then it's fine. That's not really a good way. And manual configuration, I think this is one of my biggest call outs in the community today, is that in a lot of places we don't have a way to dynamically configure alerts or metrics or like sampling rates. And I do think this is something that if you're getting ready to deploy an upgrade or do a new release, if you have to say, hey, can you add this to monitoring before the release, it's probably some workflow management that you could probably do to help improve the monitoring experience and make sure that people are able to get a wide range of coverage for when they do new releases or do deploys or do experiments within their infrastructure. And let's briefly talk about some good patterns. These aren't all of them that are listed in the book, but I just took a few that I thought was really important. And I think a lot of things that we were talking about today is composable monitoring. And this is really the first pattern of modern monitoring designs. And a lot of people will think of the Unix philosophy in this action. So we write programs that do one thing and we do it well, and then we write programs that work well together. And so, you know, when we think about this ecosystem, everything that we need in our data center is not everything, but we have data collection, data storage, visualization, analytics, reporting, and alerting, we want these tools to like work really well together, even if they're by different vendors or different open source projects or foundations. That's one of the principles that we want to make sure that we bring to our team. And then monitoring from the user perspective, a lot of people suggest in this book, monitor 5xx errors or HTTP response codes, because this is basically going to give you monitoring from the user perspective first. You begin to free yourself of worrying about individual nodes, whether or not like a database has spiked CPU. It allows you to focus on things that might actually be a problem, and focusing on your customers is the problem that you want to spend on. And then this is a very controversial topic, and a lot of people have talked about this today, whether or not you buy or not build. There's just a natural progression in the infrastructure industry kind of probably over the last couple of years to pick tools that help just solve this problem today. And then I think SaaS is the best solution. A lot of the things I'll talk about today are relatively due to the fact that when we started our observability projects years ago, compliance was an issue. A lot of the SaaS offering solutions didn't want to necessarily take on the risk of having to deal with patient data. So because of that, we had to basically stand up our own logging infrastructure within inside the company. And because of that, those are one reasons why you might have to, we still use a SaaS, we still use a vendor, but we still run it internally, basically because of the compliance concerns. But if you don't necessarily have to build something, probably don't want to. And I'll give some examples as to why. So observability is important because, like we know, living with errors in production feels embarrassing, especially after a user-facing incident. Errors were there for a while. You didn't even know that they were. And preaching these metrics and logs and traces doesn't really give you much unless you can't get granular view into your system. And it kind of makes it fairly useless. And so when we talk about some of the priorities for the refactoring that we took on about a year ago, is that we wanted to lean towards high cardinality solutions because we need to arbitrarily analyze sets of data for compliance. So whether this was adding more variables to our logs or actually just adding more labels to our metrics, we decided to do that because in the healthcare world, an auditor can come in and essentially ask us any question that they want. And because of that, we want to make sure that we want to have great visibility in our system. So if we didn't necessarily have the right question at that time, we could eventually go back with the same set of data and have the right question and get the right answer back. So that's one of the reasons why we wanted to lean towards high cardinality solutions. We wanted to make sure that our cost grows proportionally with the business. We didn't want to just start implementing crazy solutions that were very expensive and outside the need of what we actually needed. And we actually wanted to make sure that we were fitting with our fixed cost plan. And then investment in service discovery. I think this is one of the things that isn't talked about much when you probably want to start an observability project. When we talk about the manual configuration part, having a service discovery tool to be able to automatically register endpoint and discover status endpoints that are associated with those services, I think is very important. And those are things that we want to increase our usage of within our data center. And then we want to reduce gaps between our legacy and first-class monitoring systems. We had monitoring systems that we stood up day one, like almost any infrastructure, like, hey, we wanted to just make sure that we had logging and get some metrics and get some insight into our systems in place. But over time, new things came up, like Prometheus, and we wanted to find ways to be able to reduce when someone joined the team or someone wanted to add alerts or metrics to our system, what do they need to learn? Because it was very confusing when I've been at a large organization, you have so many tools, you might not actually know where's the right way to put one thing or the other. And then we want to lean towards open source projects, but for now, just stay experimental. We always in a process of looking for vendors, but for now in this approach, because we just wanted to tighten up some things around our house and just kind of update the existing operations and principles that we have. We just want to try new open source projects and see how they do, see if they can reduce the core competencies that we had in our infrastructure today, and then we can start working on introducing new features. So how do we get here? This is essentially what our kind of goal was right away. So kind of through this example, I'll be using Core DNS as an example, as an application that you might run in your infrastructure. Core DNS is open source, is an open source DNS tool. And I think it's really great because it actually provides validation for its configuration files. It also supports Zipkin support. I think Core DNS has been around since about 2010, 2011. So we'll be excited to see if they decide to convert over into OpenTelemetry tracing. And they also have Prometheus endpoint 2 as well. And so as we begin to spin up like core DNS nodes within our infrastructure for whatever reason, we should be able to just automatically go and start to get metrics on the system. So how do we think about like trying to automate this process? So if we take a step back and we look at like how we individually deploy hosts, this could be just any AMI or any machine that you deploy in your infrastructure. And these are typically the things that we would have just kind of baked into the image. We have our Prometheus exporters. This is where we went with our composable monitoring stack. And then sampling agent, if we add a label to this image that we need sampling enabled on this host, because for infrastructure, we might get a lot of vendor products that might not necessarily support sampling right away. Of course, the logs agents to forward logs off the host, a configuration agent that runs to just keep configuration in place for us. And then our console agent will be used for service discovery and any applications that we have running on this service. And then let's talk about just like how this will look in just a generic world. I just took an example from an AWS EC2 module where you can just deploy a Linux or Windows machine in AWS. And here is like what probably any standard AMI deployment looks like. Here we actually, in AWS world, it's called tags. We actually do convert AWS tags into metric labels or logging labels or other indexing information that we want to use. So that when we go get metadata about our hosts, we can be able to like trace that throughout our infrastructure. So here I just have some tags here about like it was provisioned through Terraform, the environment it run. It's going to get this core DNS image when it runs. And then this has rows of core DNS and internal. And then we have two other kind of tags there of monitoring on and maintenance enabled. And I want to talk about like why labeling was so important. And labeling is important because you want to be able to survive pager fatigue a lot of times when you deal with metrics. A lot of times when you have different roles types or you're trying to maybe experiment different things, it's always good to add probably new tags or new labels. This actually probably multiplies the cardinality that you have within your metric storage solution. But it's really good. Like we found times that where our selectors weren't necessarily right in our queries, and some of the queries were kind of just flapping and they were going crazy, or we weren't necessarily monitoring the right thing within our infrastructure. Labeling those things helped us do it. Dealing with labels is really difficult. It's starting to make me kind of feel like a database administrator at times, mainly because if you removing a label or adding a label can be very expensive. Also, when you decide to upgrade like metric names or metrics types, you might lose the previous historical data if you don't do that migration correctly. And I also seen issues of people not necessarily maintain their labels well. We've had issues of labels being kind of just left around and they weren't being used anymore, or we have like tags in attached to our AMIs that aren't necessarily applicable to the configuration that runs. So there are some like gaps that where we probably need to think about in the future for my team. And I think the meaning of your labels is something very important too for your data infrastructure world. We use tags as a way to do compliance and other things. And I had to actually propose this to my team and a couple of people around the industry. Like, what's the difference between monitoring on and maintenance on, or maintenance enabled or maintenance disabled? If you have something being monitored in production or unmonitored off in production, do you want that still being accepting requests? If it's in maintenance, do you still want to be accepting requests too as well? If a host is in maintenance, should it still be monitoring on? Should on-call get alerted on? And these are the type of things that you want to kind of have flushed out amongst your team and your organization. So that way when people go to look at metadata about a given service, if they see that monitoring on or maintenance is on or sampling is on, they can be able to infer like what is the actual state in your infrastructure as it should be, and will this toggle logging, will this toggle metrics, will this toggle your profiling on your machine? So these are things to think about when you get into your labeling process too as well. Monitoring is a multi-complex problem under the space, kind of running out of time, so I'm going to go through how we kind of evaluated some of these tools. So you either have like push, pull, both or neither. You have measurement, resolution, you have data storage, you have analysis capabilities, notification capabilities, integration capabilities, and scaling model. I think these are some of the concerns of who your stakeholders would be and the team that is going to run your observability projects. And so there's a great site at OpenAPM, and you can check out everything that's in the landscape. Pretty much it's fairly up to date. Two of the projects I'm gonna talk about today are a little weird, so they're not necessarily listed here. But agents are responsible for running as a part of your application as an independent process. Together with instrumentation libraries, they can be seen as a source of performance-related data. So here are some of the tools that are out here for agents. And then for libraries, we've been talking about OpenTelemetry today. Here are some other libraries that you can check out too as well if you're interested. And then we have some collectors here. Collectors are mainly how we receive data from the agents and instrumentation framework. So this is, depending on the type of collector, your performance data enhancement and modification is also possible inside a collector. So collectors have different responsibilities to expose the same data access API, configuration agent, or user interface from stored data. And then transport, we have like our Kafka, RabbitMQ, and Redis, and RSys log. And then we have our data storage solutions where we will store our logs or store our metrics or store our traces. So one of the problems that we had with the landscape was that it was too many tools. And we want our theory to just stick with being composable monitoring tools as possible. And so what we wanted to do was deprecate some of the old duct tape in our infrastructure and build our own if it's too opinionated, and then purchase products within our costs. So we have this kind of the Prometheus deployment here in our infrastructure. We actually use Prometheus to monitor Prometheus. So we'll have 2 Prometheus instances running to monitor each other. And if you look at Prometheus, it's very extensible in the fact that you have everything built in here. You have the alerting portion in the top right corner. You have the monitoring and the graphing at the bottom right corner. At the top left corner, you have a way to push out temporary jobs. And then you have your exporters and your scraping that happens at the bottom left. And so like, how did we get here? We needed to choose the right service discovery. We have Console running in our data center, also provides a DNS, which makes it very useful. And Console at a very high level, you run kind of an agent server model where you have a server that's handling a lot of the decision that comes in from requests. And the agents, the clients or the agents that run on particular hosts, which you saw in our image building, which kind of calls out to the rest of your data center. And then, so if we deploy core DNS, we register this service that has the core DNS metrics here. We also get the checks here on the host 2 as well for a TCP check to make sure it's there. And then in our Prometheus scraping, we'll use the Console service discovery. There's other service discovery tools here to be able to scrape all the services that we know will have metric endpoints, and then start to do some relabeling here. And then, here's some of the labeling that we add here for the monitoring and maintenance, and we'll make decisions based off this on what to alert on based on those labels and other ones. And another tool I just want to quickly talk about maybe in the last minute or so is choosing a new forwarder. We start off with a vendor solution, mainly because logging is very hard to implement on your own, and it was very easy to use a vendor. So we had small tools that work well with other parts of our stack, and we wanted to experiment with new tools for a while before we decided on what to pay. One project I would tell you to go check out is Vector. Vector is a little bit more than just kind of like a log forwarding tool, but it does some transformations here. So it's really fast. It's vendor neutral. They have a lot of components that plug into different parts of your stack. It's one tool, so you don't necessarily have to worry about deploying all these different things. It's bundled all together. You have these programmable transformations, so you can transform to different things. And then you have guaranteed. And this is what a sample transformation looks like. Let's say I'm sampling getting logs from Nginx, and I want to kind of filter out or add some sampling to there, and then I want to put it in Elasticsearch and S3 as an archive. So I'm running out of time here. Go check out this Vector project if you're interested in having something that's a little bit more extensible for logging and transformations. I want to give it back to Paul.